You know, there's literally thousands of satellites up there.
I wonder how they stay up there and orbit the Earth.
What do you mean?
Well, why don't they just float off into space or crash down to the ground?
Ah, it's because of centripetal force.
Centripetal force?
Yeah.
What is that?
Well, give me your cup. Thank you. And I'll show you how it works.
Okay.
Stand back.
Okay. How does a satellite orbit the Earth without falling or flying away? What forces exist when an object has circular motion? Does speed affect the forces on an object with circular motion? Let's find out.
Welcome to the moon, to the Kong, to the simple, to the science. That's right, we're back at a Moon Kong Simple Science experiment. And last night I was looking up at the stars. And I thought, you know, there's also many thousands and hundreds of satellites up there. So how do they stay up there? How do they orbit the Earth and not fall down and not fly off into outer space? Well, I did some research and I found out the answer has to do with centripetal force. Sounds like a big word, but it's a simple concept. So we have some experiments today to look at centripetal force and how it works. Okay, for the first experiment, I just have a glass of water. You can see that there. Now, right now, this glass of water is being affected by gravity pushing down on it. I know that because if I turn the cup upside down, the water comes out. Just because when a substance or an object is only affected by gravity, it will fall. But what do you think happens when an object is affected by a force other than gravity as well? Well, let's move on to the second experiment and answer that question. To investigate that question, I have here another cup of water, and it has some strings attached to it. You see that there? We're going to go outside and give this cup a bit of a twirl and see what happens to the water inside. Let's go. So that was pretty cool, right? The water didn't come out of the cup. Well, there's a couple of reasons for this. First, when I spin the cup, it has a force that makes it want to move up and away from the center. But because it's attached by the string, there's also a force pulling it back towards the center. This center-seeking force is centripetal force. The two forces balance each other out, and the result is a circular motion. Because of this circular motion and the centripetal force, the water stays in the glass and doesn't come out. Pretty cool, huh? Well, for the third experiment, we're going to take a look at what happens when we slow down the spin of the circular motion. So, once again, let's go outside. Okay, so this time you saw that the same thing happened as the second experiment. The water and the cup both spun and it stayed in. But when I began to slow the speed of rotation down, the cup stopped moving in a circular motion and the water came out. This is because when you slow down the speed of rotation, you reduce the strength of the centripetal force. So that force wasn't strong enough to keep the water in the glass anymore, and because of gravity, just like our first experiment, it fell out. Okay, so we learned that without any other forces acting on an object, it will fall down because of gravity. Secondly, centripetal force is a center-seeking force of any object in a circular motion. And finally, if we slow down the speed of rotation in that circular motion, we reduce the strength of the centripetal force. So this is a really cool experiment. Don't use this experiment with your mom's china or precious glasses. She'll be very angry. See you again next time. Bye-bye.